Next question. A horizontal heavy uniform bar of weight W is supported at its ends by two men. So this is a rod which is supported at the two ends by two men. One end is on the shoulder of the first guy and the second end is on the shoulder of the other one. And then what? You know, when as at the instant one of the men lets go of his end of the rod, you know, this guy is actually giving his end, and then what happens? This rod is coming down like this. Then the question is, the other feels the force on his hand change too. Okay, so we have the ends of the rod kept on the shoulders of two men here. And then what? One end is let off like that. So what happens now? Let us redraw the figure. This is the first guy, right? And he has one end of the rod, and then the rod is now moving down like this, right? You know, the other end, the other end has been let off, which means what? You know, that end is moving down, which means what? It was actually in the horizontal direction. It has now what? It has now turned through an angle theta, right? Turned through an angle theta. It is a kind of rotational motion. So the force on the shoulder of this guy has obviously changed. Earlier it was F by 2, right? The weight mg, no? Look at that. You know, this is force on the, weight of the rod is acting through the center of mass. Weight of this rod is acting through the center of mass. The normal reaction on this shoulder is F, on this shoulder is F. Both the guys are equally sharing the weight. Correct. So, for translational equilibrium, we could say what? F in the upward direction plus F in the upward direction should be mg in the downward direction. Right? Obviously, we have translational equilibrium here. Which means what? The net upward force must be equal to the net downward force. Upward force on this shoulder is F, on this shoulder is F. They are identical now because both of them equally share the weight. Okay? Right. So F plus F should be equal to what? The weight is mg downwards. So it is what? 2F is equal to mg, or F will be equal to mg by 2. That means weight by 2. That means each of these guys would get weight, half the weight on his shoulder, half the weight. Okay? But in the changed scenario, you know, obviously there will be lesser force on this body. Right. I'll come back to that. Okay. Anyway, as it is rotating, tell me what? I can write down the equation for torque. Torque is equal to I alpha. You see this equation, no? It is executing a rotational motion, no? So I can write torque is equal to I alpha here. Now, torque can also be written as what? Torque can be written as, you know, the center of mass is here, no? Center of mass is here. Center of mass was here. This is where the weight was acting. Weight was acting, mg. And it is rotating about this shoulder of the first guy, right? Now, as you let this end off, what happens is that end is executing a rotational motion like this. Rotational motion. So, who is causing this rotational motion? The weight of the body, which is acting through the center of mass, is causing a rotation. He's causing a rotation motion here, right? So how do you find the torque? Torque is equal to force into perpendicular distance, right? So I am actually finding what? Finding the torque on this rod about what? About this shoulder, about this end, about the end which is still on the shoulder, right? So I can find torque as what? Force into perpendicular distance. That makes it what? mg into L by 2. If L is the total length of the rod, you know, weight is acting through the center of mass. So torque is what? Torque is force into perpendicular distance. The force here is mg. Perpendicular distance from the point of rotation is, axis of rotation is L by 2. So mg into L by 2. So I could equate these two. This is equation number 1, equation number 2. What do we get upon equating? I alpha is equal to mg into L by 2. But I value, you know, this is what? This is a thin rod rotating about its end axis. A thin rod is rotating about its end axis. For a thin rod, if it rotates about its end axis, the moment of inertia is mL square by 3. Hope you remember. Moment of inertia of a thin rod as it rotates about one end is mL square by 3 into alpha is equal to, this is mg into L by 2. So let us cut L's on either side, then m's are gone, then you get alpha. Alpha is equal to what? This 3 will go over to the right hand side. That makes it 3g over 2 is already there and L goes to the right side. 3g divided by 2L. right? So I'm writing it here. I have the angular acceleration. This is actually angular acceleration, right? I need to find linear acceleration now. So I'm going to write down an equation for this. You know, having found angular acceleration, I can find linear acceleration by taking r times alpha. Because you have seen this in circular motion, no? Basics of circular motion. Linear acceleration is equal to radius times angular acceleration. Linear velocity is equal to radius times angular velocity. V is equal to r omega, A is equal to r alpha. So let us put the value. What is r here? As you can see, I am looking at the center of mass here, no? So the distance is L by 2. L by 2. So the distance is L by 2. So L by 2 into alpha is what? Alpha is written 3g over 2L. L and L are cut. What do we get? That is 3 by 4 times g. Okay. Now, if the normal forces, the new normal force is F. If the new normal force here is F dash, the old force was F, the new normal force is F dash now, F dash. I assume that the new normal force is F dash. I can write down an equation for this point now. How do we write the net force? Net force. Net force can be written as, it is coming down with an acceleration, no? It's coming down with an acceleration, right? So I can write the downward force mg minus the upward force F dash. There is only one normal reaction now, right? Normal reaction is F dash. The other end is let off now, right? Only this end is being supported now, so that it has a normal force F dash. Mg is the downward force. It is coming down, so downward force must be greater. Mg must be greater. So I take mg minus F dash is equal to ma. What I want is F dash. So F dash goes to the right side, ma goes to the left side. So F dash will be equal to mg minus ma. That is equal to mg minus, what is A? A is 3 by 4g. So m into 3 by 4g. So this is like what? This is like mg minus 3 by 4 mg. That means mg is weight. Mg is weight minus, this is 3 by 4 times g. I have just substituted for A. Acceleration is what? Acceleration is 3 by 4g from there, no? Acceleration is 3 by 4g. So I could take W minus 3 by 4 times mg is still what? Mg is W. So 3 by 4 W. So W minus 3 by 4 W is W by 4, 1 by 4 W. So the new force on his shoulder is what? It is W by 4. Initially it was W by 2. Currently it is W by 4. It is easy. You know, one end is being released, and then what happens? There is a rotational motion, and finding torque using the equation I alpha, and torque is found out using another equation. Force is acting through the center of mass. So for this force I can find the torque by taking mg into distance from the point of rotation, axis of rotation. So mg into L by 2. I alpha is equal to mg into L by 2. I put the value of moment of inertia because it's a thin rod that is rotating about an end axis. So solving it, I get alpha. I can find the linear acceleration, then A is equal to r alpha. Okay, so I take this r alpha. The weight is acting through the center of mass, so I take the distance L by 2 there, right? So I can find what? I can find I can write down an equation for the net force now. Net force is what? One force is F dash. The normal reaction is F dash. Normal reaction is only here because there is only one shoulder that is supporting now, right? So F dash, mg downwards. The net force will give a linear motion, right? So mg minus F dash is equal to ma, right? So F dash will be equal to mg minus ma. That makes it mg minus m into 3 by 4g. So m into 3 by 4g is w by 4. Answer is 3 by 4 w. Answer is w by 4. Answer is option B.